Now here we see the integrals of the form given by root of a square minus x square, root of x square minus a square, and root of x square plus a square. Now if you recollect, we had seen very similar looking terms but in the denominator. So we had solved the integrals of the type where these expressions inside the square root were present in the denominator, but now they are in the numerator. Now we'll solve, or rather derive, the formulae for these types of integrals using integration by parts as well as the previously seen standard results. Now there is the same procedure for all of these three. So let's take just one example out of these, say first one. So let us try to find out how to evaluate integral of root of a square minus x square dx, right? Now as we just saw that this has to be solved by parts. So what do we do is, let's consider this root as nothing but the first function, because that is what is to be integrated, and we consider 1 as the second function, right? So that is given by first function into integral of second function, right, minus integral of, now in the second integral we have derivative of the first function, that is derivative of root of a square minus x square into integral of 1, and all of this integrated with respect to x. So that further gives us, now integral of 1 gives us x. So let me write that x first, so that we have x into root of a square minus x square minus integral of, now derivative of root of 1 upon, root of a square minus x square will be 1 upon 2 into root a square minus x square into, now we have to multiply by the derivative of a square minus x square, which is minus 2x by chain rule, right? And multiplied with the integral of 1, which itself is nothing but x. So we have to multiply by that x again, dx, right? So that further gives us x into root of a square minus x square minus, if you see 2 can be cancelled, in fact there is one more minus sign inside, so we can take it out and make it plus, and what we are left out with is x square upon root of a square minus x square, right, dx. Now if you observe, the x square term is already present in the denominator as well as numerator, but in the denominator it is negative. So let us do one thing, let us keep the negative sign as it is, alright. So therefore here we have minus of x square inside, and as well as we have the minus sign outside. Okay. Now how do we adjust the denominator in the numerator? So for that we can see that if we add and subtract a square, then we will get the desired term. So the first term is as it is, that is x into a square minus x square minus, now here first of all we add a square, then write as minus x square as the first term, but we must subtract a square because that is what we had added on our own, whole upon root of a square minus x square, right, dx. So therefore that gives us, this is I. Here we have x into root of a square minus x square minus. Now if you observe the first term after breaking the fraction, a square minus x square upon root of a square minus x square will be nothing but root of a square minus x square in the numerator, and which is nothing but the given integral. So therefore we can write it as integral I, right? And in the second term the two negative signs become plus, and then after that we have a square taken out because it's a constant, and we have to integrate 1 upon root of a square minus x square. Right? Alright, now let us continue. So therefore based on this we bring I on the left hand side, so we get 2i on left hand side equal to x into root of a square minus x square which is the first term, plus, now in the second term a square is constant, so it will remain as it is, and integral of 1 upon root of a square minus x square is a standard formula as we have seen earlier, and that turns out to be sine inverse of x by a, which is one of the standard results that we have seen earlier, sine inverse of x upon a, plus say c1, which is a constant of integration. So therefore finally we have to divide throughout by 2, and hence we will get the answer as x by 2. So after removing we will get it as x by 2 into root of a square minus x square plus a square by 2 sine inverse of x by a plus the constant. So that is the way in which we integrate these types of integrals using integration by parts.